Here's our lesson on transformations in the coordinate plane. So I'm going to walk you through this, and then I will do a couple practice problems for practice B, and you guys can work on this while you are at home. So the first one is circle the letter that best describes each transformation. So we are going from the object on the left, and then it is being transformed to the one on the right. And you can tell because on the left it is STUV, and then on the other side it is S prime, T prime, U prime, V prime. You can see that little tick mark there. So just taking a look at the answers. So we have a 90-degree rotation, we have a reflection across the x-axis, reflection across the y-axis, and then a translation 4 units right. So it is definitely not being transformed across the x-axis because that's right here, so we know it can't be B. Is it being translated 4 units to the right? Doesn't look like that because some of them look like they're being moved more than 4, so it's not this one. Is it a rotation about the origin? Nope. But it is a reflection across the y-axis because reflection is a flip, and you can see that this is just getting flipped because that V is ending up right over there and it's being flipped. And remember in class we talked about using your hand to actually move it to do the flipping. So number 2 is a translation 4 units left and 4 units down, translation 8 units left and 7 units down, reflection or a rotation. So if it was a rotation, it would be in like a different position because it would have been turning somehow, so I know it's not a rotation. Reflection across the x-axis would end up moving from here to here, so it's not a reflection. So let's take a look and see what we might notice. Translating 4 units to the left. So let's see. I'm going from B, and I'm going to count 1, 2, 3, 4. It's moving more than 4 units. Let's see. 5, 6, 7, 8. So it looks like it is going 8 units to the left, and then we can double check and count 1, 2, 3, 4, 5, 6, 7, and 7 units down. Use the graph below for exercises 1 through 3. So we have A, B, C, D, and we need to translate it 2 units to the right and 3 units up. What I'm going to do actually is I'm going to write down what these coordinates are for each one. So A is at -3, -6. B is at -6, -6. C is -6, -2. And D is -3, -2. So if we are translating A 2 units to the right, which is going to go 1, 2, and that's going to be at -1. And then we have to go 3 units up, 1, 2, 3, so that's going to be at -1, -3. I'm just going to erase this, be a little bit clearer. With B, we're going 2 units to the right, so we're going to end up right there, and 3 units up, 1, 2, 3. So that's your B point. So erase that. And that is at -4, -3. And then C is going here 2 units to the right. And then 3 units up, 1, 2, 3. So it's actually right there, which is -4, -1, right? 1, 2, 3. Okay, there's a mistake with this problem right here. It is -4, 1. I wasn't counting correctly. And D, we have same thing, -3, -2. We have -1. 1. Okay, so what I'd like you to take a look at is, do you see any patterns here? Is there anything that we could do to make this a little bit easier for us instead of doing all the counting? Well, this is why I put the original coordinates right here. If you are going 2 units to the right, which coordinate are you changing, the x or the y? You're changing your x. If you're going to the right, are you going to be adding or subtracting? So you'll be adding. So you're going to take all of these x values and add 2. Take a look. -3 plus 2, -1. -6 plus 2, -4. -6 plus 2, -4. -3 plus 2, -1. Now if you take a look at going 3 units up, which value are you changing? You're changing the y value. 3 units up means +3. So -6 plus 3, -3. -2 plus 3, 1. That's another way that you can look at this. Instead of trying to count along with the boxes, you can just do straight math. Let's take a look at the reflection across the y-axis. So we have our y-axis, it's right here. So we need to do a mirror image of the rectangle and flip it over. So let's take a look at some shortcuts. We can do the counting like we had earlier. We can go ahead and say, well, point A is how far away from the y-axis. 1, 2, 3. And then we can then just go 1, 2, 3, and that's our new A. Or we can say, it's going to be 3 spaces here, 3 spaces here, so that's 6. 6 total spaces, we need to flip that over. So why don't we take that x value and add 6. So -3 plus 6 would give you 3. And is that where our new dot was if we moved it? It is, it's at 3. So what's happening with our y value? Is it changing? It's still the same. So go ahead and look at what you wrote up there and keep your y values. In fact, for all of these, you can keep your y values because nothing's happening with them. They're staying the same. Our D, point D, is right above point A. If we had to move our A 6 total spaces, we can do the same thing with point D, and that would give you the same x value of 3. If doing the math is just a little bit too hard, you can still just go ahead and just physically move them, and that might make it a little bit easier. Okay, so let's just take a look at it and go ahead and move D. We want to, it's going to take 1, 2, 3 points to get to here. It needs to be symmetrical. Mirror image on the other side, 1, 2, 3. So that's where it's going to be, right there. And you can see that that is point 3, -2. See, 3, -2. So that is still an option for you if you're not comfortable with the mathematical component yet, and that's okay. So now we're looking at B, which is down here. So how far is that away? Well, we've got 1, 2, 3, 4, 5, 6. So that's 6 away, which means it's actually going to be 12 because we have to go 1, 2, 3, 4, 5, 6. So you can see that this new point is going to be 6, -6. If you added 12 to that x value, -6 plus 12 is 6. And the c value, because it's right above it, will be the same. Let's take a look at the rotation. 180 degrees about the origin. Remember, these are the ones that are a little bit harder for me. So 180 degrees. If we rotated it, pivot foot rotated up to here, that's 90. And then if we rotate it over here, that's 180. So remember I had said that I would literally like take a piece of paper and just kind of keep shifting it around? Well, I found something a little bit easier. This shape down here is entirely in which quadrant? It's in quadrant 3. And it's going all the way in quadrant 1. Now, because we're rotating it, what do you think is going to happen with those coordinates once they hit quadrant 1? They all need to be positive because everything in quadrant 1 is positive, positive. Well, because we're rotating it about the origin right here, what do you think is going to happen to this -3, -6 for point A? If it's up in quadrant 1, it's simply going to be 3, 6. And then point B would just be 6, 6. Point C would be 6, 2. And point D would be 3, 2. I think I found an easier way to do these where I don't have to worry about spatial stuff. So let's take a look at practice B. So here is practice B. I'm going to go through just a few of these for you and I'll let you work on the rest. So of course, the first thing I did is I wrote down the coordinates for the triangle for A, B, and C. And I'm going to do A prime, and I'm going to do it mathematically first. So when it says 4 units to the right, that's going to be a +4 because it's going to the right. When it says 5 units down, that's a -5. But which values are we going to be adding or subtracting to? Well, 4 units to the right, left and right, is going to be going to the x, and up and down will be affecting the y. So mathematically, I'm going to take point A here, -6, 4. -6 is the A. -6 plus 4 is -2. And 4 minus 5, or 4 plus -5, will give you -1. So let's say you're not comfortable with the math part yet. And you can still do the counting. So let's go ahead and take a look at point A, 4 units to the right, 2, 3, 4, and 5 units down, 1, 2, 3, 4, 5, and you end up right there. So you can still physically do that with these, or you can try looking at the math for a little bit of a shortcut. Sometimes the math helps because you don't have to worry about miscounting one of these grids. So number 2, a reflection across the x-axis. So when we reflect this, if you can just picture my hand taking this and waving it down, like we did in class today, just bringing that down, flipping that over. And so you're going to end up having something that looks like this. It's going to flip back up. Okay, so a couple ways we can look at it. We can, so A is still going to be down in quadrant 3. And to get from A to the x-axis, where that's the line of symmetry in a sense, it's 1, 2, 3, 4. So you got 4 to get to here, and then you're going to go 1, 2, 3, 4. And then you end up right down there. So it's going to be -6, -4. And then I'll let you finish the rest for 1 and 2. Now this last one, this rotation. I was looking at this and then thinking about what I did on the other page, and I realized something here. We're rotating 90 degrees, so we're just going from here to here. And in the other problem, we rotated 180 degrees, and so that was turning twice. And when we turned it twice, it ended up just changing from the negatives to the positives, and the x's and y's stayed the same because of the way it was turning. But here it's not exactly going to work that way. So when we're turning point A, and this is where the spatial awareness can be a little bit difficult, we know that both of these have to be positive. But when we actually turn this, so think of B as that pivot, as that hinge, and I wish you could see like my fingers moving this here. This A actually is coming up right here as you're moving it. And then, if you notice, this is 4, 6. Not negative 6, 4 with the original, but 4, 6. So look what happened. The X and the Y switch positions. With B, it's not as easy to see because they're both 1s, but B on that little hinge is going to end up right here. And it's 1, 1, but in a sense it's switching. They're both being positive. And the C is following right along, and that's going to end up right there. And that's going to be at 1, 6. Oops. And so it looks like that. I think when you see it drawn in there, it makes it a little bit easier to kind of tell what's happening with these little movements. And that's the hinge that's just right here, is just being pivoted. So rotations for me are hard. I know we did all 3 of these. So what I'd like you to do is work on finishing up 1 and 2 and describe the transformations in 4 and 5. Now there may be more than one. Obviously in 4 it looks like you've got more than one thing going on. And if you notice when we had our transformations, we always talked about changing the X first and then changing the Y. So we're going to talk about moving left to right and then going up and down. So in number 4, we're moving this guy to quadrant 4. And we're going to go left to right, then up or down. Okay. And then I'll leave you alone on that one. Good luck. We will go over more of this when we get back on Friday.